Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is check if move is legal. Let's go to LeetCode and give this problem a read. So you are given a 0 indexed 8 by 8 grid called board, where board RNC, that particular address, row and column, represents the cell on the game board. On the board, free cells are represented by basically a dot, and white cells are represented by the string W, and black cells are represented by B. Pretty simple so far. Each move in this game consists of choosing a free cell, changing it to the color you are playing as, either white or black. However, a move is only legal if changing it, the cell becomes end point of the good line, of a good line, horizontal, vertical, diagonal. So basically there are 8 directions. Now a good line is a line of 3 or more cells, including the endpoints. Endpoints have to be the same color. The playing color could be either black or white. There are no empty cells in between. That's what make a legal good line. Now where the endpoints of line are one color and the remaining cells in the middle are opposite color, no cells in the line are free, means there are no cell in that line is a dot. You can find good example for good lines in the figure below. I'll go over it, but let's finish up the description. You given two integers, R move, C move, and the character color, basically W or B representing the color you are playing as, white or black, return true if changing that particular cell to the color is a legal move, or false if it is not legal. Alright, so that's a hell of a description, but I'm sure you have understood some of it. If not, let's go over it and you'll find how easy it will become. Alright, so we are playing a game. And for that game, we have a board of 8 by 8, matrix. And these cells in this board can have 3 characters. You can say one is dot. So everything you see here, right here, this blue is basically a dot, right? It's basically a string dot, or you can say period. And then this black color is basically a B, it's a B, and all the whites are W. Now, you are given this R move and C move that represents basically the address, the row and column, and the color B. This is the current player that will be making a move at these particular positions. So this is the X is the position. Basically, X is the position. Basically, 4th row, 0, 1, 2, 3, and 4. This is the 4th row and 3rd column. So 0, 1, 2, and 3. This is the position that we are trying to make the move. And color is black. Now we will be placing this B black over here, right? Now, after placing this, the game is asking us to check 8 directionally, horizontal, vertical, and all the diagonals. So towards the corner, we are trying to find this way, diagonal, and this diagonal. So these are the 8 directions we will be checking. If placing B right here makes a legal move. What are the legal moves? Well, legal move is a move that will create at least one out of all the 8 directions, at least one good line. What is a good line? Well, this is a good line, 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 and this is a good line. And this one is not a good line. Let's understand why these 4 are good lines and this one is not. So let's say if we had a move where the player with the black color was making the move, and let's say this particular position that person chose right here, then what you're going to do is to make this a good line and make this a legal move, we're going to search, let's say in left directions, if we are considering this as a section of the board, then we're going until the end to the boundary. This could be either one of the sides of the board, or it could be one of the corners, right? So if this is what we're considering, then it has to end with the same color as this one. This is a black color, then it has to end with the black color. Then in between, everything has to be the opposite color. All right, opposite color. So this, and without any empty cell, without any dots. All right, so this is white, this is white, and that's why it is a good line. And this was a legal move. Now here, let's say if we're choosing this particular cell, so, and let's say white person is playing, then we're going up to check until the very end. This white person is represented with, and when I'm saying white person, it's not white person. What I'm saying is like person with white color as a player. Okay, so this is W. So W, and you're gonna go up and you find the end is also W, and there is at least one cell with the opposite color. So this is opposite color. All right, let's say here, if we were choosing this one as the cell with the black color, so, and you place the black color and you try to look, this is not a good line, because immediately there is another color present. Like basically we were looking for all the opposite color, and this is not the same color. This is not black, this is white, and also in between we see the same color that we made the move. Okay, so now we understand. And this is diagonally, so black, and in between there is white, and here it's white. These are diagonally, and there is black in between. All right, so now we understand what is a legal move. Legal move is what makes the whole line good. A good line is what has these properties that we just understood. Now this is a kind of like a section of the game. This is, we are maybe writing, like, if you see the real scenario, we are basically writing a piece of code from the whole game where you're checking if that move is legal, right? It's not, you're not writing the entire game here, you're just writing a piece of game. So now the whole thing depends on like going in all the 8 directions. 8 directions I've already told you. This maybe it's better to use this color at this point. So these are all the 8 directions. These are all the 8 directions, and we're gonna go over all the 8 directions to check. Go all the way up to end, and while you are going, make sure that you reach the end of the either borders or diagonals, and then you check the color present is the same color, and then in between you did not see the same color, and you did not see any empty cell. All right, any empty cell. And you can see right here, if we check right here, well, while placing this B black right here over here, and this one is a legal move because everything in between is white, and this in also legal move. All right, so now let's write the code. Okay, so let's declare our directions that we will be visiting. So I have written it right here. Then we are going to implement this function. First, we'll come back to it. Let's visit all the directions. So dr and dc in directions. So we're gonna go over all the directions, and then we are going to send these to basically check if the move is legal. So we can create this inner function saying that if let's say is move legal. So that's the inner function we'll be writing. It's going to take dr and dc. So these direction, if it brings the value true, then we're going to return true. Otherwise we can return false. All right, otherwise we can return false. Now let's write this function. Right, this function is move legal. All right, and it's taking dr and dc. All right, dr and dc. Now what do we want to do? First thing is we want to make basically these new row and new column using these directions. Let's create a new row and column. Let's call it R and C, and then we are going to add the directions to this R move, right? Those are the moves that is given to us for row, and for column it will be DC plus, let's change it to C. Okay, now we have chosen a direction, and we're gonna go until the end in one of those directions. These are 8 directions, so either we want to go all the way up to those 4 corners, or for these boundaries. Another thing is, like, we're gonna have this count variable to count the number of another color that we are seeing. We need to have at least one opposite color in between the same color that's given to us right here. Okay, so what we're going to do first, we'll have the while loop to take us to the boundary, and first thing, let's create a check, not check, it's like is valid. Let's create is valid move that is taking our R and C and telling that it's a valid cell. And this I'll implement this function just right now, but before that, this board at R and C, it's not empty. Okay, we don't want that because it's given to us. It's not empty, and it's not also same color. Okay, it's this particular cell is also not the color that we are making the move. It's not color. If these things are safe, then we can keep going, right? What we can do, R, C could be, I can just copy this thing right here, and even this thing right here, yeah. So we can keep going. In that direction until we can't anymore, and we can keep incrementing the count because we are seeing that opposite color. All right, let's implement this thing right here. Before legal move, so I'll have another inner function taking the row and column, and what does it return? It returns true if row is greater than equals to 0, and C is greater than equals to 0, and row is, well, less than 8, and column is also less than 8. 8 is the size of the board that's given to us. Okay, so this is what we return is valid. You don't have to have this. We can, instead of is valid, we can just place this piece of code, but like it looks better if you do it this way. Now once we have reached those boundaries, we'll exit out because this is valid will not return true. Otherwise, maybe we will fail from one of these situations, right? So at this place, what we want to check, well, first thing we want to check is that the color, current color, because you are exiting out, the current color has to be the opposite color. So how do you check opposite color? First thing, let's check is valid. It has to be valid, right? It has to be valid. This needs to be valid, and count has to be greater than equals to 1, because that's the opposite color we were counting, and the position has to be the opposite color, right? So no, not the opposite color, the same color, because we are ending with that color. We were looking for this particular color. Okay, not the opposite color. And if that's the case, then we can return true. Otherwise, we will return false. Okay, we will return false. And I guess that will be it, guys. That is our sweet, simple code. Okay, so let me zoom out. I was already zoomed out. Okay, I was already zoomed out. So that will be it. Now we can simply try to run our examples and see if so if R and C invalid syntax. Yes, C is less than. Yeah, that's it. Oh my god, I just made this really stupid mistake right here. It doesn't, this is not what we are adding. We are going in that direction, but like we're going with the current row and column. Okay, not, you can't keep adding the same value because at the end you're stuck in the same loop. You're going to that move again and again and again. So that was something we were doing incorrect. Yes. All right, let's submit our answer, and hopefully this is the best solution because beats 4%. Let's submit it again. That we don't have premium. Let's submit it again. All right, 100%. See, sometimes it's not just the code, it's this speed of the internet. So time complexity would be big of 8 into 8, right? 8 into 8. So that is like basically constant time, you can say. And then space complexity. Are we using any space? Well, no. We are like we're creating directions, but that's also constant. So let's say that is also big of 1. All right. Now that is it. Let's go back to AlgoYogi and mark this problem solved. See you guys in the next problem. Until then, bye-bye.